Okay, hello students and welcome to a new topic. Now this topic you would not have really covered before in maths, and so a word of advice is that you may not find it terribly complex in the sense that some of these concepts are fairly simple, but you'll find them challenging because they are concepts that you've never come across before or have never really seen them expressed this way. So I'd like you to pay particular attention to these. So we're going to start off in chapter 8 of your textbook, and it's the network chapter, and it's related to critical path analysis. And when we think about critical path analysis, it involves project work. So a project often involves many related activities, some of which cannot be started until one or more earlier tasks have been completed. Now, one way of scheduling such activities that takes this into account is to construct a network diagram. So it's about efficiency and making decisions. So what we want to look at this lesson is we want to be able to construct a network diagram to represent the durations and interdependencies of activities that need to be completed during a project. So that might be traveling from town A to town Z, for example, or even just preparing a meal or preparing a project. So we're going to define a few terms like network, node, and arc, and then we're going to create a network diagram from a map and an activity table. Before we get started though, let's have a look at this problem here. So this has been a bit of a problem solving exercise. And people have wondered if it was possible to cross all the 7 bridges here without crossing it more than once. So take a little bit of time and see if you can cross all 7 bridges without going over them twice. So you may want to try and draw. So, oops, I can't do it there. So your turn to have a go at a few of those. That one there. When we look at networks, you're going to be quite familiar with this term network, or you'll be able to recognize it pretty quickly. So if we travel to Brisbane, you know that there's a train network. We know at school there's a computer network. We also know about the World Wide Web and that we're all interconnected. We also have a power network, so that gives us electricity. We also have Facebook, if you're an old person like me, or you might have some other sort of social network that you're going to be using. And you also know that, for example, your blood is networked around your body through the circulatory system. So we're familiar with networks, but we may not have seen them expressed in this way. So let's define, first of all. So a network is a collection of connected objects, and these connected objects will be arcs and nodes. So an arc is this line that joins 2 nodes together. Now this arc is a directed arc because it's got an arrow on it, so that makes it a directed network. Sometimes you'll see this diagram called a diagraph, and that just means it's a diagram which has a directed representation in it. So the lines here are called arcs, and we have the nodes here. To start off in this chapter, we're going to give the nodes a letter, and we're going to give the arcs a value. When we move on next chapter, it will change a little bit. So what have we learned? We've learned that a network is a collection of nodes and arcs, and a directed network has those arrows on the arcs indicating the direction of the flow. When we have a look at a map, we can redraw a map in a way that is simple. And so we've got here a road network, and it kind of describes the roads around BCC, how to get from BCC to different places. So it takes, for example, about 20 kilometres, especially if you're going to go out by the ring road to get to Sugarland. 10 k's down through Bargara to get to Nielsen Park, and Hinkler Shopping Centre is probably about 15 k's away. and the post office further into town as well. Now we can draw that much simply by just, first of all, giving each node a letter. So we've just nicked the N off Nielsen's Park, and we've nicked the B of BCC, and so on. And we've simplified this diagram. And so that helps us to express all the detail in the map in a simple network. Now you can see that this is not a directed network because there are no lines on the arcs though. So the first task now I'm going to get you to do is consider the network below, and we want to find the shortest path from point A to point B. Now there's going to be a general rule is that you can't backtrack on this one. So let's have a look. And when you attack these in a test, I would suggest grab a highlighter. So I'm just going to use a coloured pen at the moment. But when you see these in the test, you're going to go, okay, I can go A to C and C to B. So we're saying A, C and B. Well, we just add those up, and that's going to be 14 that way. I can also go A, C, D and B, and that's what 8 plus 5 is 13, plus another lot is 21. I can go that way, or I can choose A to D to B. 7 and 8 make 15. So the question is, what is the shortest path? Well, the shortest path has got to be the smallest number. So the shortest path then is going to be listed off as the nodes A, C and B. So to answer the question here is to travel between C and D would increase the distance a little bit, wouldn't it? So the shortest path then is ACB, and that's the smallest number. So let's have a look at the impact of the arrows. So according to the network below, what is the shortest path from A to B? Well, we've got to start at A, and we notice that we can't go that direction because of this arrow. So we've only got to go from A to C. Can we go from C to B? No, there's an arrow blocking our way. So we've got to go down from C to D, and then we've got to go from D to B. So therefore, the only available path is A, C, D and B, and we just list off those nodes as the path. The next activity we will come across is that of an activity table. So an activity table is just a list of activities, I suppose. And in this activity table, I've drawn an imaginary school, and I've said, well, we've got A, B, C, D and E block. And I've drawn the distances from each of these blocks from each other. Now, I want you to notice a few things. If I join A to A block, it's going to be 0. So I've just left that blank because that doesn't make much sense. But I can see if I'm going from A to B block, it's going to take 20 meters. So I actually can draw this on a network diagram like this, and I can write 20 meters there. Now, can I go from A to C block? No, there's no path from A to C block. Can I go from A to D block? No, I cannot. But I can now go from A to E block. So I can draw in a path from A to E and write in a distance. Let's draw that in again. And I'll write the distance in a different color, seeing that's both black. And I'll put that one in as 20 as well. So an activity table, as I have said, is a list of activities. Now, you'll see that if I need to repeat myself, I've just left it blank. So all of these down here are left blank. In fact, I could leave this line out altogether. So we've just got the important values listed. So let's continue now. We've done all our A block line. Let's look at a B block line. Now we're going to start at B block, and we want to say, can I get from B to B? Well, that doesn't make sense. So I'm in here. So I'll do this in purple. But I can go from B to C block. So where's B? And I'm going to have to cross over this path. And from B to C block, it tells me it's 40 meters. So I write in 40 meters. I'm just going to write the 40, and that's that one done. I can also go from B to D block. So where's B to D? So I just draw that in. Nice and straight if possible. It's a bit harder for me on here. And it's going to take 30 meters. And so that's that one done, that's that one done. Now B to E block is 50 meters. So let's draw that in. And we'll put in the 50 meters. So you can see straight away, year 12, that this diagram needs to be big. You'll notice that I've had to rub out a few things, and I've had to need to use that space wisely. So using pencil is always good on a network diagram, and making it a bigger space. I think I've created too small of a space here. So it's going to look a little bit cluttered, but I'll continue through it because we're nearly done, and we'll have a practice at a couple more hopefully. So now let's look at C block. We want to go from C block, we're on here, let's try maybe green, that stands out. Now C to D block. So where's C? Yeah, well, I can go from C to D. And I was using a thick pen. And C to D took 20 meters. And then C to E also took 20 meters. So I go back to the green. And I'm just going to try and fit that in. So C to E. And I'll write the value in. So that's 20 meters. So that's that one and that one done. Finally, the last measurement we're going to draw in is that of D block. Now I'm going from D to E. I'll use a thick pen because I've set that pattern. And we're going from D to E, and that's what, 15 meters. So we'll write that value in. So we've now created a network diagram from an activity table. I suppose we should also be able to work backwards on that. So let's have an example of doing that now. So let's work backwards now. I've got a sample network down below, and I want to fill in an activity table. So it's a fairly similar network to before, but I want to read from the network. And so I'm going to start off with the first line, that's A block. And I want to read. Can I go from A to B? No, it's not connected. What about, so I could put a line there if I want, or I could just leave it blank. I could go from A to C. So that's 50 meters. Now, can I go to A to D? No. Can I go from A to E? No. So let's now go to the next row. We're going to look at B block. Can I go from B to B? Well, that doesn't make sense, so we'll just put a line there. And what do we do next? I can go from B to C. Yes, that's going to be 30. Can I go from B to D? Yes, that's 20. Can I go from B to E? Yes, I can. That's 40. Okay, let's do the next line. So that's C block. So I'm looking at C. Well, I've already talked about C and B. I can't really go from C to C. So we're going to now look at, can I go from C to D block? Yes, I can. So that's 50. And can I go from C to E? No, there's no line connecting. So I leave that blank. Now, last of all, let's look at D block. So here's D. And I'm leaving all of these blank. So can I go from D to E block? Yes, I can. And that's going to be 40. Now, remember we said we don't need to put E down there because it's already covered in this part of the activity table. So the next part of the activity would be to consider what's the quickest way to get from A block down to E block. And we're going to just run through how we do that. So we're going to go from A to C is to 50. So I've just put a little 50 there. Now that's all the nodes that are one node away from node A. Now A to C is 50, so A to C to D is going to be 100. So I'm just going to write a little 100 there to keep that in my mind. Now from A to C to B, well that's 50 plus 30, so that's going to be 80. Now I can also go from A to C to D to B, and that's going to be 120. Now I can also now look at from A, C, D down to E, so that would be 140. I think that would be the quicker path, so I'm just going to add on another 40 from there, so go A, C, B and then E, and that would take in 120. Now all I would do is I would highlight that path, so like so, and I would state that A to C to B to E took 120 meters to walk. So there are a few things that aren't in this activity table, like the steepness of the slope, etc. But this tells us the shortest distance because that's the information given in the activity table. Okay, students, we can see that I've changed this diagram up a little bit. I've added in a few things. I've added in a line that crosses another one here. So that adds to a little bit of clutter. So I could have chosen to draw the line out like that, and that's fine. Or I could have chosen to draw F over here, and that's fine for your diagrams. So it doesn't need to necessarily look the same in everyone's book. The problem is that you're going to be doing a little bit of reworking your diagram. So you will probably need to draw this in pencil and use a different decent size diagram. Let's run through this diagram now. So task A to A doesn't make any sense, but I can go task A to B. No, I can't. What about task A to C? No, but I can do task A to D, and that's 20. Can I go task A to E? No, I can't, but I can go task A to F. Can I go now B? I can't go anything from B. I can't go to B to A. That doesn't make sense. B to C? No. But I can go from B to D, and that is 15 hours. 15 hours in this one. And B is connected to nothing else. So I may as well be putting in these lines here. Task C. Now let's have a look at C. I can go from C and D, and that's going to be 18 hours. C is connected to nothing else. Let's go now to task D. So is D connected to E? Yes, it is. It's 31. And is D connected to F? Yes, it is. That's 23. Now let's look at the last activity. Can I connect E and F up? Yes, I can, and that's 26. I could analyze this for shortest path, and you can use that process I showed you before, but I just wanted to show you something that had something other than kilometers in it or meters in it, and could show you that you could assign it to tasks. So networks are good for drawing complicated things in a simple fashion. It helps us to visualize a process. It also helps us to make decisions and to multitask. What I would like you to do now, folks, is to work on exercise 8A, and that's on page 431 to 433 of your textbook.